Hello friends, in this lecture we can discuss some of the concepts related to damped vibration. So what is damped vibration? So when there is a reduction in amplitude takes place over the cycle of vibration, we can call that as damped vibration. So from the diagram we can easily understand how the damping is taking place and how the amplitude slowly reduces and reaches to a mean position. So here, because of this damping, certain amount of energy is dissipated to some other external system. So because of that, it the amplitude slowly decreases and reaches a mean position. Next, we'll see the various types of damping. The first one is viscous damping. So viscous damping is mainly the damping provided by the fluid resistance, mainly hydraulic oils, which provides cushioning effect in shock absorber. So that is a very good example for viscous damping. The next one is Coulomb damping. So Coulomb damping is arising because of the sliding between dry surfaces. So when two surfaces which are under dry condition slides, there will be friction created and also frictional force also will be acting into that particular area. So we can represent the frictional force acting in this situation as F, that is frictional force equal to mu into N, and mu is the coefficient of friction and N is the normal force. The third one is solid or structural damping. So this damping is mainly because of the internal friction within the material itself. So here there is no need of any external force or external body, but it is internally taking place within the material itself. And the fourth type of damping is the damping provided by the surface irregularities. So when two surfaces are in contact or which are kept one above the other, okay, because of the irregularities there will be some interlocking which will take place, and that will provide a kind of damping which is called as interfacial damping. The next we can see a term which is called as damping factor or damping ratio. So it is the ratio between actual damping coefficient to the critical damping coefficient. So we can represent this as C divided by C suffix C, which is equal to C divided by 2m omega n. So here the critical damping coefficient is the amount of damping required for a system to be critically damped. Next definition is logarithmic decrement. The definition for logarithmic decrement is the natural logarithm of the amplitude reduction factor. So here it can be represented as delta equal to natural logarithm of xn divided by xn plus 1. So here xn divided by xn plus 1, that is amplitude reduction factor, which is nothing but the ratio of two successive amplitudes. Next we can see vibration isolation. So vibration isolation. How to isolate vibration? So in some of the cases, especially in workshops or in machine shops, we have to isolate the vibration so that the vibration which will be created by one machine tool should not be transmitted to the nearby machine tools through the foundation or through the floor on which it is mounted. So we have to isolate this type of vibration, otherwise it will affect the performance of the neighboring machine tools. Finally, it will affect the productivity of the full or entire plant. So how to isolate this type of vibration? So by providing springs or dampers, okay, at the base of the machine tool. Okay, we can prevent a transmission of the vibration from one machine tool to the other machine tool. It is called as vibration isolation. Next we can see a concept or term called transmissibility. So it is the ratio of force transmitted to the force applied. So it is also mentioned as isolation factor. So here the force is applied in the form of disturbing force which makes the system to vibrate. This may be any force, external force, which creates the system to be in continuous vibration. And force transmitted is the force transmitted by means of spring or damper or dashpot. So it is transmitted through the vibration damping material. So that is called as force transmitted. Thank you.